My name is John Ford. I'm going to be talking about linear and nonlinear regression today, as it applies to the Antoine equation. So first off, we're going to have a collaboratory file here. We're going to have this raw data, and we're going to copy this link, use get and copy that link in there. It's going to allow us to pull the data right from our code, and then we're going to start importing. So import numpy as np. That's going to allow us to do calculations. And then this next one, we're going to use a minimize function. So from setby.up minimize, import minimize. And then we're also going to be creating plots. So from plot a dot subplots import make subplots. Alright. So now we're going to create our array. So data equals numpy load text, and then we're going to load the file name, water vapor pressure csv delta equals. Alright, just make sure we have our array here. Nice. So now we're going to assign variables. Temperature is equal to the first column, so that, and then pressure is going to be equal to the logarithm of the second column. Alright, now we have our variables assigned. We're going to create the first plot. So fig equals make subplots. So we're going to have one row and one column. And then we're going to make it a scatter plot. So fig.add scatter. X value is going to be temperature, Y is going to be our pressure, then mode is going to be markers to create points, and name is just, we're just going to name this one data. Alright, so here we have our first plot. Now we're going to want to use the sum squared error to create a nonlinear regression. I'm going to type out the code first and then go to the whiteboard and start explaining there. So we're going to define sum squared error as v, and then our variables we're using a, b, and c. It's going to be equal to v. And then we're going to return the equation. So the equation is going to be a sum, because we're using sum squared error. Sum, it's going to be log p minus a minus b over temperature plus c, and then we're going to square this value just to make sure all of our values returning from this equation are going to be positive. There we go. So we have the linear regression of a, b, and c. It's going to be equal to, we're going to minimize it. Minimize. And we're going to use the sum squared error function. And then we have to make initial guesses for each of the A, B, and C. So there's going to be 1, 1, and 1. And from here, we're going to create our second plot. So fig dot add scatter. X is going to be our temperature again. However, this time y is going to be equal to the Anton equation. So we have A nonlinear minus B nonlinear divided by T plus C nonlinear. And then our mode this time is going to be lines to create a linear regression line. And then we have our name is going to be the antoine nonlinear regression. So, as you can see, the initial guesses worked. We're going to come back and create better initial guesses. As you can see, the nonlinear regression, it's got a straight line here. It's not a very smooth curve. So I'm going to take it to the whiteboard, and then I'll work it out and then give a close-up so you can see better. So let's see. We have P is equal to A minus B T plus C. So here's the sum of this. So alright, so for the sum squared error here, sum squared error is just to make sure that the nonlinear regression is the best possible item. It's going to minimize and make sure that it's just the least possible error that you can have. So now to create the better guesses, we're going to do some matrix multiplication. So I'm going to write it out again and then give a close-up. So from here we have P is equal to A minus B over T plus C, multiply each by T plus C, T plus C, P is equal to A times T plus C minus B. And then to create it, so we're going to be able to do matrix multiplication and have the log of P, just multiplying each out, is equal to AT minus C log P plus B A C minus B. Now this, due to our matrix, we're just going to call this whole thing, it's going to be D. So we go here. We have our temperature 1, 2, 3, all the way down to n. Then we have our negative log P1, log P2, P3, Pn, then just a column of ones. Then we have A, C, and D right here. And then that matrix is all going to equal way over here. It's going to go down here. T1 log P1, T2 log P2, then Tn log Pn. Alright, so now we are going to multiply the, let's label this as x, this is v, this is y. So to make this into linear regression, we're going to take this to the top over here. It's a little bit easier for you to write. We're going to take it, we're going to go x transpose, we're going to multiply each side by the x transpose, so x transpose times x times v is equal to x transpose times y, and then we're going to need to multiply it by the inverse of this function right here, so that x transpose times x inverse times x transpose x times v is equal to x transpose x, and then x transpose y. And then grab this equation out here, and this is going to be our linear regression. So let's get a close up here. So we got this. We have the equation here. Shimmy it down to this over here. Put it into matrices down here. Label them out x, v, and y, and then multiply it by the transpose each side, and then multiply it by the inverse on each side, and then everything cancels. We're left over with v equals x transpose times x inverse, and then x transpose times y. Alright, now back to the code. Alright, so first got to make our matrix inside of the code. So we're going to make our matrix here. First value t, we got negative log p, and then we have our column of ones. So we np ones, ones like, and then like t, that will just make it so the same amount of values of ones come out as the same number of values as t. Now, we're going to start doing the matrix multiplication we did back here, and that's going to be our linear regression. So we have our A, we have our C, and our D, and that's going to be equal to the inverse. We have numpy linear algebra inverse of x transpose times x, and then we're going to multiply that by the x transpose, and then we're going to multiply that by temperature times log p. Now, we'll do this in here. So we do not want D, we're going to want C, so it's going to be the B linear is also equal to, just by shimmying around, we're going to have B linear is equal to A linear times C linear minus D linear. Alright, so let's see. now to get our good initial guesses, we're going to type it out. Just have A, B, and C come out, and that's like good. So we can type them in here. It's not going to make a big difference since we already have the nonlinear regression here. So -34. Just put that in again. All right. So now to fix this straight line here, we're just going to want to put a bunch of values of t in there. So we have code here. T plot, we'll call it t plot, is equal to when space. Oops. And then we have the minimum of t. Oops. The maximum of t, and then we are going to have, we'll just put 100 values in there, and then change this over here. And as you can see, that has gotten rid of that straight line, has made it more of a nice curve in here. And then, so that's our nonlinear, and then we've got we're gonna do the same plot except for have our linear regression in there. So instead of this, just take out all these ends, and then we're gonna name this line antoine linear regression. There we go. Let's go. Let's just restart it all. That way we don't have a bunch of unnecessary lines. And here we go. So, as you can see, both of them look pretty close, the nonlinear and linear. But when we take a closer look down in here, you can see they are in fact different lines. It's a very negligible difference, but that's going to be it for me today. I hope you enjoyed, and have a nice rest of your day.